In this video, we're going to go through the Topic 7 test review. So for the first 3 problems, we are using inverse, cosine, sine, and tangent to evaluate for an angle. And so they're asking us to write our answer in both degrees and radians. So one thing to remember is that there are restrictions on inverse sine, cosine, and tangent. So for inverse cosine, in order for this to be a function, we're ignoring quadrants 3 and 4 because that's when it starts to repeat. So when I'm looking at cosine, I'm looking at the x-coordinate on the unit circle. And so because I'm looking for a positive 1/2 as the x-coordinate, I know I'm going to be in quadrant 1, not in quadrant 2, because that's where cosine is negative. Quadrant 1 is where cosine is positive. So what I'm looking for is on the unit circle, where is the x-coordinate positive 1/2? So you'll have this formula sheet on your test. So if I'm looking at the x-coordinates, x is positive 1/2 here. And so that means that my answer is 60 degrees and pi over 3. 60 degrees and pi over 3 radians. For tangent and sine, I have a different restriction. So the restriction for sine and tangent, in order for those two functions to be a function, I'm looking at only quadrants 1 and quadrant 4. So sine is positive in both quadrants 1 and 2. So ultimately these restrictions are taking one quadrant where it's positive, one quadrant where it's negative. Remember that the funky thing about this is that technically it's going from 90 to negative 90, but we can answer the question in terms of the larger value, and I wouldn't mark you wrong on that. So since I'm looking for when sine is negative radical 3 over 2, when I'm looking for sine to be negative radical 3 over 2, that means that I'm looking for sine, so the y value, to be in quadrant 4, a negative radical 3 over 2. So the y coordinate is negative radical 3 over 2 here. So this is 300 or 5 pi over 3. So if I look at this in terms of what's given on the unit circle, however, in terms of how I should write my answer, 300 is negative 60 degrees, right? And so I get that by subtracting 360. And then 5 pi over 3, if I subtract 2 pi, that gives me negative pi over 3. So the answer for this problem is 60 and then negative pi over 3. For tangent, it has the same restriction as sine. So in order for tangent, inverse tangent to be a function, I can only look at quadrants 1 and 4. And again, in quadrant 1, tangent is a positive number. In quadrant 3, tangent is a negative number. Remember that tangent corresponds to y over x. And so in order for this to be equal to negative 1, these need to be the same value, but the opposite sign. Okay, so in order for something to cancel to 1, I have to have the same value. Since I want negative 1, they need to be the opposite sign. So if I look at my x and y coordinates here, notice that at 7 pi over 4 or 315, those are positive radical 2 over 2 and negative radical 2 over 2. So if I were to take negative radical 2 over 2 and divide that by positive radical 2 over 2, notice that that is negative 1. So that means that our answer is those coordinates, which were the degree 315 and the radian 7 pi over 4. Remember that if I subtract 360, that means that this is equivalent to negative 45 degrees. And if I subtract 2 pi, that means that this is equivalent to negative pi over 4 radians. So negative 45 and negative pi over 4 radians are the answer to number 3. Number 4 is an equation where I am answering using degrees to the nearest tenth. And so that means that I should be using a calculator for this. So I don't have 0.8 on the unit circle. So I need to make sure that my calculator is in degree mode, and I'm going to use that to solve. So if I have sine theta equals 0.8, that means that theta is equal to the inverse sine of 0.8. So to isolate theta, I have to take inverse sine of both sides. And so that gives me this value. These are the problems where we're remembering that there is more than one place for sine to be positive 0.8. So when I calculate this, so if I do 0.8 and then do inverse sine, my calculator gives me 53.1, so nearest tenth is about 53.1. If I think about where that answer lies in quadrant 1. Okay, so it means that here I have an angle of 53.1. Okay, so since I have sine as a positive number, where else, I wrote out the word sine, sorry, positive sine. So since I have sine as a positive number, I have to think about which other quadrant sine is positive. And so all students take calculus tells you which trig function is positive in each quadrant. So that means that it's also going to be positive in quadrant 2. So what I have to do is figure out what this angle represents in quadrant 2. So remember that the 53.1 is the reference angle. So that is how far away the angle is from the x-axis. So if the x-axis is 180 degrees, I'm going to have to take and do 180 minus that 51.3 to determine what the value is in quadrant 2. So 180 minus 53.1 tells us that in quadrant 2, the answer is about 126.9 degrees. So theta is equal to 53.1 degrees and 126.9 degrees. For numbers 5 and 6, notice it's asking me to solve the equation on the interval from 0 to 2 pi. So that tells me that my answers need to be in radians, and I need to use the unit circle. So our first job is to isolate the trig function, or trig functions if I have more than one. So in problem 5, the trig function is sine x. So I want to get that by itself, which means I want to start by adding 1 to both sides of my equation. And so I end up with 2 times sine of x equals 1. Then I have to divide by 2. So this tells me that sine of x is equal to 1/2. Which means that x is equal to the inverse sine of 1/2. So I'm going to look on the unit circle for every place that sine, so y, equals 1/2. Okay, so x is going to be equal to every value on the unit circle where the y coordinate is 1/2. So if I'm looking at the unit circle, just at the y's, the first place where y is 1/2 is pi over 6. So pi over 6 is my first answer. The next place that y is positive 1/2 is 5 pi over 6. So that is my only other answer, because notice that the next y value of 1/2 is negative. right? So those two are negative. So it's only pi over 6 and 5 pi over 6. Remember, when I'm looking at a single trig function, my answers should always have the same denominator when I'm talking about radians because they have that same reference angle of pi over 6. So x is equal to pi over 6 and 5 pi over 6 for the solution to negative 1 plus 2 sine x equals 0. Structurally, the problem for 6 is the same in the sense that I'm going to solve for a trig function and then use the unit circle. What makes it complicated is that I have multiple trig functions. And so when it's equal to 0, that's a hint that you should factor. Okay, so what I'm doing when I'm factoring is I'm undistributing the trig function that's in both terms. So notice that both terms have a cosine of x. So what that means is I'm going to factor out the greatest common factor, which is cosine of x. When I'm factoring out cosine of x, think about it like undistributing. So cosine of x divided by cosine of x is 1. Cosine times 1 makes cosine. The next term is negative root 3 times cosine of times tangent of x. So if I divide by cosine, the cosine is going to disappear and the rest of it is going to stay. So I get the square root of negative square root of 3 times tangent of x. So again, if I were to distribute this back, notice that I would get those two terms. So that's how I check to make sure that I factored appropriately. When I factored, I now have two separate equations. The first equation is that cosine of x is equal to 0. The second equation is that 1 minus 3 tangent of x is also equal to 0. So 1 minus the square root of 3 times tangent of x equals 0. So cosine of x equals 0 tells me that x is equal to the inverse cosine of 0. Remember that this is the x coordinate on the unit circle. So I'm looking at where on the unit circle is x equal to 0, and I'm going to answer using every radian measure. Oops, sorry. So x is 0 at pi over 2. And then again at 3 pi over 2. So the only two places that x is 0 is pi over 2 and 3 pi over 2 radians. So x equals pi over 2 and 3 pi over 2. So that's 1/2 of our answer. 1/2 of our problem is done. We also have to solve 1 minus the square root of 3 times tangent of x. So that means that we want to move the 1 over so that tangent can be isolated. So negative radical 3 times tangent of x is equal to negative 1. And so if I divide that by negative radical 3, that tells me that tangent of x is equal to, since they're both negative, I know it's going to be positive. So one thing to be careful about with tangent is that it's always y over x. And so what happens is it gets simplified, which can make it a little more complicated. So it's always simplified by the denominator. So if we think about these points in the unit circle, if it's not a whole number, it's over 2. So that means that I can go back and think about this as being 1/2 over radical 3 over 2. What I have to be careful about is that tangent is positive in quadrant 1 and in quadrant 3. And so I know that my two answers are going to come from those two quadrants because it's going to be this and it's going to be negative 1/2 over negative radical 3 over 2. Okay, so I'm looking for both of those points to be the answer for this equation. So this second part of my answer, I'm looking in quadrant 1 for when y is 1/2 and x is radical 3 over 2. Then in quadrant 3 when x is negative 1/2 and y is negative radical 3 over 2. So y is 1/2, x is radical 3 over 2 at pi over 6. If I go across, it should take me to the other answer. So tangent works good that way. So then 7 pi over 6 is my other answer. Notice this would be the negative divided by a negative makes a positive. So our two answers here are pi over 6 and 7 pi over 6. I'm sorry, there wasn't quite enough room for all of that in the box. Okay, so one trig function, you just solve it, should have two answers. Two trig functions, you have to factor out the one that's repeated and solve each equation separately. Usually you're going to end up with 4 answers. Okay, so then number 7 is looking at identities. So you will be given all of the identities that we've talked about on your worksheet. The only thing that you're not given everything of, again, is law of cosines in the area of a triangle. So you have to be able to switch out the letters, right? If I'm looking for, if I know angle B instead, I would have A and C, and I can switch those things out for all of these formulas. The only formulas that you'll need in terms of identities are these 3. So reciprocal, quotient, Pythagorean. Pythagorean identities are the ones that are squared. So if I'm looking at secant squared minus 1, I'm going to take this identity and manipulate it. So I'm going to rewrite that identity. So the Pythagorean identity tells me, sorry, let me spell this out better. So the Pythagorean identity tells me that 1 plus tangent squared theta equals secant squared theta. So what can I do to make this side match what I was given? I can subtract 1 from both sides. So if I subtract 1 from both sides, that tells me that tangent squared theta is equal to secant squared theta minus 1. So that means that my answer is tangent squared theta. For problem 8, I'm looking at a triangle, GHJ. So let's lay out all of our angles. Triangle GHJ. And then GHJ. So we are given that the measure of angle H is 42 degrees, that G is 18 inches, and that H is 32 inches. So they want us to find the measure of angle G. So our unknown is G. We know the side across from it. Our other knowns are angle H and side H. So when I have this where I either want to know and know or know both, so if I have 2 capital letters somewhere going on in my problem, whether it's an unknown and a known or 2 known angles, then I am going to use the law of sines. Okay, so this tells me that we're going to use sine of G over G equals sine of H over H. So again, you're given all 3 of them in terms of A, B, and C. Remember that you only ever use 2. So if you have 3 different letters and you can't find the other letter using the sum of a triangle, then you're going to use the law of cosines. For law of sines, you have to have 2 of the same letter for one angle one side, one angle one side in order to use it. So all I did was switch the A's to G's and the B's to H's. Remember, we're ignoring the J's because we didn't need that. So if I plug these values in, sine of, I'm just going to leave G as G because that's what we're looking for, over 18 equals, sine of 42 over 32. And we have to cross multiply to solve. So I'm going to multiply 32 times sine of G and set that equal to 18 times sine of 42. since I want G as my answer, I have to divide both sides by 32. So that's going to give me that sine of G is equal to, and let's calculate that. So 18 times sine of 42 divided by 32 gives us 0.3764. And so in order to find G, remember we have to do inverse sine to find an angle of that 0.3764. I would just use my answer from the calculator. I'm not going to type in that rounded value because it will change the validity of my answer. So if I do inverse sine, that gives me about 22.1 degrees. So G is 22.1 degrees. So again, because I know an angle and I want to know another one, that's my clue that I'm going to use law of sines. For problem 9, they give us triangle PQR. And so let's lie. It's not a G. PQR. So they tell us that side P is 10 feet. That side R is 14 feet, and that angle Q is 40 degrees. So when I know two sides and the other angle, so not an angle across from one of those sides, that means that I'm going to use law of cosines. So they're asking me for length Q, right? So this is my variable. I'm looking for this one. I guess I'll use a question mark. Okay. And so that means that if I know angle Q, side P and R, I'm actually going to be using this law of cosines formula. However, I'm going to change the A's to Q's, and then the B's to P's, and the C's to R's. Okay, so we're going to use that formula. Again, because I know two sides and the other angle, not an angle that matches one of those sides. So if I knew the angle that matched one of those sides, I would be using law of sines. Okay, so let's write out what the equation would be. So it would be Q squared equals P squared plus R squared minus 2 times P times R times cosine of Q. Oops, not theta Q. And so let's plug those values in. So P is 10 plus 14 and so I'm going to type all of this into the calculator. Remember that the important part is if you're using a calculator that works as this one does, you're not hitting enter until the very last step. Okay, so you're not saying equal until the end. If your calculator shows you the display, you're typing it in exactly as you see it. So I've got 10 squared plus 14, plus 14 squared minus 2 times 10 times 14. I'm not touching equal, times 40 cosine. Then that's my answer. So then I hit equal. So this tells me that Q squared is this number 81. We're just going to say 0.5 for now. So 81.5, I guess I should do 4 decimals, 5076. So that's Q squared. To find Q, I'm going to take the square root of both sides. So this tells me that Q equals the square root of this. So again, I'm using square root answer or just taking the square root, about 9.0. So it's telling me to round to the nearest tenth. So one decimal place would be 9.0. The 2 is going to keep it. So Q is 9.0. Ooh, feet. Sorry, I almost 9.0 feet. Make sure that you use units if they give you units for your answer. So for number 10, it's asking us to use everything from the previous problem to find the measure of angle P and the measure of angle R. So I'm not going to rewrite the information. Let's just use it to solve. So in order to find P, I need all the sides. So if I set up the formula for cosine of P, cosine of P is going to be equal to R squared plus Q squared minus P squared over 2 times R times Q. So now that we know that side Q is 9 feet, we have enough information to solve for an angle. So we're going to plug 10, 9, and 14 in for each of these values. So we've got 14 squared plus 9 squared minus 10 squared over 2 times 14 times 9. So remember that for this, in order to get P by itself, we have to take the inverse cosine of this ratio. My pen's not right. So what we need to look at is doing P equals, there it is, inverse cosine of this fraction. So if I evaluate 14 squared plus 9 squared minus 10 squared, that's 177 over 2 times 14 times 9 is 252. So if I evaluate that fraction, the inverse cosine of that fraction in my calculator, that gives me a value of about 45.4 degrees. Okay, so we know one answer now. So the measure of angle P is about 45.4 degrees. I'm going to add it over here too. Which means that in order to find the last angle, all we have to do is take 180 degrees, because we know all the angles in a triangle add to 180, subtract the 40 degrees, and subtract the 45.4 degrees. And so that's about 94.6. So that means that the measure of angle Q, sorry, not Q, the measure of angle R must be about 94.6 degrees. For problem 11, we've got the angle of elevation from a viewer to the top of a flagpole is 65 degrees. If the viewer is 25 feet away and the viewer's eyes are 5 feet from the ground, how high is the pole to the nearest tenth of a foot? So we've got a flagpole, and then we have a person. So they're saying that this person is looking at the flagpole at a 65-degree angle where they're 5 feet tall, or their eyes are 5 feet tall. So I know that this little piece on the flag is also 5 feet. And that they are 25 feet away from the pole, and they want to find the height of the pole, right? So this is our answer, right? So the pole is going to be whatever this distance is that we don't know, plus the 5 feet. Okay, so that's how we're going to get our answer. So our unknown right now is this portion of the pole that let's just call X. Okay, so I need to figure out X in order to figure out the length of the pole. Okay. So based on the triangle that I have, I'm assuming the pole is vertical. I know the angle is 65. 25 is the side adjacent to that angle, and the height I want is the side opposite. So what that tells us is that we can use the trig function tangent to solve. So we're going to use tangent of 65 is equal to opposite over adjacent, so x over 25. To get x by itself, we want to multiply by 25 on both sides. So x is going to be equal to 25 times tangent of 65. So let's calculate that. So 25 times tangent of 65 is 53.6. So it's nearest tenth, so 1 decimal, 53.6. So that's that one portion of the pole. So I'm going to add 5 to that. So that means that my answer is 58.6 feet. Okay, so the pole is 58.6 feet above the ground. The area formula when I have a side angle, side triangle is given to us as the area equals 1/2 b times c times sine of a. So I know an angle and I know the two sides next to it. So if I'm using the variables on my problem, this is side p and this is side q. So I would do that the area is 1/2 pq times sine of r. So if we plug in 1/2 of 8 times 9 times sine 110. My suggestion, just to make sure you don't take a lot of time calculating or type in something wrong, is when you have half and an even number, I would always take half of that even number. So 1/2 of 8 is 4. And then you can just type in 4 times 9 times sine 110. You can even go further and know 4 times 9 is 36 times sine of 110. If you're not comfortable with your multiplication skills, then at least do the reduce just so you have a little bit less to type in. So that means that I would have 36 times sine of 110. And so that gives me 33.8. So this is 33.8. They didn't give us units, so I need to write units squared. So 33.8 square units. The rest of these are identities. So I'm looking at my identities, which are across the bottom of my formula sheet. Again, you're just looking at your notes because you don't have that yet, but when you're doing the test, you're gonna look at those values. So remember that if I have trig functions that are not squared, that means I'm either gonna use reciprocal or quotient identities. The goal is to be able to kind of cancel things out or to square things. And so if I have secant, I really only have one option. So secant of x is 1 over cosine of x. So I'm going to change secant of x to 1 over cosine x. And then for tangent of x, cotangent of x, I have two options. I can make it 1 over tangent. If I multiply it by 1 over tangent, notice that that's not going to be helpful. I'm still just going to have something multiplied by something else. So I'm not going to do that. So I've got 1 over cosine of x. Sorry, I need to switch back to green. I thought I did. 1 over cosine of x. And instead of using 1 over tangent of x for cotangent, it's better for me to use cosine over sine. So if I use cosine over sine, cosine x over sine x, I'm actually able to reduce my cosines and get 1 over sine of x. And so if I look at the right side of these identities, notice that I have this. So that means that my simplified form of secant times cotangent is actually just cosecant of x. Okay, so the last two are where I'm placing things in order. So it works like our cut and paste activity that we did. So ultimately, what you should notice is that the last one should be easy because the last one is your goal. So I know that's last, right? If I look at problem 15, I know that that is last. So how many blanks do I have? 1, 2, 3, 4, 5, 6. So I know that that's the 6th step for each of these problems. Okay, so you can get that one right very easily. So whatever's last, count how many steps are, that's the last step. So manipulations are going to go kind of in order. So I have secant x over cosine x minus tangent over cotangent. So the strategy that we just used where we're changing things to sines and cosines, if you look at our steps, that's what they did. So what I'm looking for is something that changed each numerator to what it's equal to. So secant of x, if I think about my identities, is equal to 1 over cosine. So I'm looking for something that has 1 over cosine in place of this secant. Okay. So 1 over cosine in place of the secant looks like this one. So then let's check. Tangent is sine over cosine, so that's good. And cotangent is cosine over sine. So that means that this is actually the first step of my 6. Okay, so the next step should be simplifying this in some way. Since this is a complex fraction, it would be something where I multiply by a reciprocal. So the thing that multiplies by a reciprocal, so 1 over cosine times 1 over cosine, and then this one times this reciprocal, notice is this, the third blank. So that's going to be step 2. Step 3 would just be simplifying this. So if I look at the top one, notice I just multiplied cosine times cosine makes cosine squared. Sine times sine makes sine squared. Cosine, cosine, so that's step 3. When I have two fractions, I can combine them to make a common denominator. So notice that if I bring those together as one fraction, this should be the numerator. And so that means that this would be step 4. And so what's left should be step 5. If we think about 1 minus sine squared, that's this Pythagorean identity, right? So if I were to subtract sine squared from here, I would get cosine squared. And so that is the 5th step, which then something over itself is always 1. Okay, so let's follow that same kind of strategy for the next one. So I started with 1 over tangent plus tangent. And so if I look at what's going on, it looks like I can look at this in terms of, oh, they changed 1 over tangent is cotangent. So the first step here is changing 1 over tangent to cotangent. After this, notice that everything has sine and cosine. So I'm looking for the one that changes cotangent to cosine over sine and tangent to sine over cosine. And so that's this one. So this would be step 2. So since I have two fractions, notice they start to come together, right, to create an answer. So that would mean that I would need a common denominator. So if I wanted a common denominator, I would have to multiply them by each other's denominators. So this step is giving them a common denominator, multiplying the first one by cosine over cosine, the second one by sine over sine. When I have a common denominator, then I can bring them together, okay? So now I can write them as the same fraction. And then remember, whenever we have sine squared plus cosine squared, that's the Pythagorean identity. So that turns into 1. Okay? And so that's why this is the 5th step. And then again, we can think about 1 over sine is cosecant. 1 over cosine is secant. And so that's why that's that 6th step. Okay, so that is how everything will look on your test. Make sure that you know how to do each problem individually. And redo them as many times as you can to make sure that you've got the concepts going.